Alright, so we're going to look at a few problems from section 1.2. The first set is when you're given graphs of relations, how to determine domain and range. And again, when you're reading a graph, you want to remember that the inputs or the x values are part of the domain. The outputs or y values are what are part of the range. So again, when you're reading domain in this first one, you're looking for the x values that get hit. All right. So there's no points back here, and again, I'm just going to look for the x values. There's no points until I get to here at -3, and then all along here there are points, in fact above and below, until I get to here, and then the points stop. So points only exist along the x-axis from -3 to 3. Okay. For range, again, you're looking for y values. Okay. There's no points down here, so the range doesn't really start until you get to -6. Then all of these y values are part of your graph. You have some of the graph on the left and on the right, and then they stop here. Okay. So the range goes from -6 to 6. Okay. Part B, we have a parabola. But again, for domain, we look along the x-axis. Now, one thing you want to be careful out here, you would assume, or we would have to make clear, that these ends extend indefinitely. Okay, so the left end continues to go up and to the left, the right end goes up and to the right. So when you're looking at domain, all these x values have points. They're very far up, we can't quite see it, okay, but if you extend this graph, you would see that there would be points. And so as you go across, all these x values are part of your domain. Okay, even way out here, there would be points up to the right here. So the domain here would be all real numbers. For range, again, you're looking along the y-axis. There's clearly no graph down here. The graph doesn't start until about right here, which I'll take to be -3. Okay. And then from there, it goes up, and there's always points to the graph there. Okay. So the range starts at -3, but then continues on to infinity. Okay, and then finally part C, we have a piecewise function. So again, it doesn't really matter where the pieces are or how many. For domain, we look along the x-axis. So there's no points back here. The points start, it's not real clear here, but I think it's supposed to be about -4. So the points start there. There's points until you get to 2, and then it stops. There's a little bit of a gap. It picks up again at 4, but again, remember, it's an open circle, so it's just after 4. And it continues there till 6 and then stops. So the domain went from -4 to 2, and then the other piece was 4. Keep in mind that's a parentheses because it's not included, to 6. Okay. For range, again, we're looking down here. There's no graph until about -6. Okay, and again, that's an open circle. Okay, but then there's a graph for a while over here to the right. When we get up here, there's graph left and right, which is fine. Keep going, there's still graphs. Still graphs. Even past 4, we have a graph. There's only one, but that's fine. It's still part of our range then, all the way up to 8. So our range goes from open circle, -6, up to 8 bracket. Okay, then one other type of problem that we do in section 1.2 is just evaluating functions. So we have two problems here. One is when you're given the function's formula, and the other one when you're given the function's graph. Okay, either way you should be able to get some function values. Okay, so the first part, we're just asked to evaluate f at these 4 different places. Okay, keep in mind we're given f of x equals -x minus 3. It's a little bit better always to think of it as just this function, because we're not given x ever. It just takes any input, let's not call it x anymore, it takes any input, takes its opposite -3. So this is the function that takes an input, takes its opposite and minuses 3. Okay, so for f of 2, we take its opposite and -3. So it's just -2 minus 3 or -5. Okay. Again, f of -1, this function takes the opposite of the input, -3. So 1 minus 3 would give us -2. F of A, again, it doesn't matter what we put in, we take its opposite minus 3. There's not much more we can do except write negative A minus 3. And then F of 4t, again, your function takes the opposite minus 3. And again, not much to clean up, but we could call it negative 4t minus 3. Okay. Second problem, again, a different function. We're not given the formula, but we are given the graph. And you should be able to read function values from the graph. So we should be able to plug in 2, 1, and negative 1. Okay, remember the inputs represent x values. Okay. Be a little bit careful here, right? Because you have the window here which shows that you're counting by ones on both scales. So if I want f of 2, x has to be 2, so I go over 1, 2. I can see my point is up here. Okay. That is the point 2, comma, 1, 2, 3, 4. But again, that means when I plugged in 2, I output 4. Okay, the y value is your output. F of 1, I go up to this point here, which is 1, comma, 2. So f of 1 is 2. And f of negative 1, again, inputs are x values, so you go x to be negative 1, and then we go down, in this case, negative 1, comma, negative 2. So f of negative 1 is negative 2. Okay. And then finally, the last three, it's a slightly different question because now we're given the outputs. Remember, the outputs are y values. So we're looking for the input that results in each of these outputs. Okay, so if I want the output to be negative 2, remember that means the y value. That's down here at negative 2. So I want this, all these points, any point that gives me an output of negative 2. I have one here and I have one here. So for part D, let's write this over here. F of negative 1 is negative 2, but so is f of 1, 2, 3, 4, 5. So there's two inputs that give you an output of negative 2, which is fine. For part E, we're looking for outputs of 2. So again, that's up here. Y equal to 2 is this high. So any points along that line. Here's a point that gives output of 2, and here's another one. Okay. So f of 1 is 2, and so is f of 3. And then finally for part F, we're looking for inputs that give an output of 0. Okay, well again, y value is 0. That's the x-axis, in fact. So we're looking for any points along here, which is here. F of 0 is 0. And over here, which is 1, 2, 3, 4. F of 4 is 0.